Good day, I'm 3D Teacher Win and welcome to another lesson about waves. So for this video, we are going to talk about electromagnetic spectrum. So you can read more information about it on pages 79 until page 82 of your science book. So we are going to talk about your electromagnetic waves in everyday life. So actually, there are many types of waves. We have sound waves, light waves, radio waves, water waves, and so on. So some type of waves are classified as electromagnetic waves because of their electric and magnetic nature. So let's try to look at what are its importance in our daily life. So your electromagnetic waves or your EM waves are important because we can control our television set, not only television set, any device that needs remote. So we can use it or we can control the device using the remote control keypad. Also, we are able to receive live telecasts of events happening in another country. So if you're listening to radio or if you're watching your television or even watching YouTube videos or any live telecast, so thanks to EM waves, so we are able to watch it. Also, we can communicate with someone in another country, so you can use your internet or it can by using your telephone or your mobile phone. Also, so we can also use a microwave oven to cook. So these are some importance of your EM waves. So actually there are lots of information as we go on with this video. So the following types of waves are electromagnetic. So we have here your gamma rays. We also have your X-rays. We also have your ultraviolet rays or your ultraviolet radiation. We also have here your visible light, infrared radiation, microwaves, and also your radio waves. So as we go on to the next slide, so we can see there, so the particular wavelength and the energy each wavelength is possessed. So this is like your spectrum of your EM waves. So we're in, as we look at from the left going to the right, so we have here your radio waves until to the smallest one, which is your gamma rays. So as we can see here, if you can still remember your wavelength, so as we go on, or if you look at your radio waves, so the wavelength, what's again your wavelength? So your wavelength is your distance from crest to crest. So this thing here is your wavelength. So from radio waves, so the wavelength is longer, right? And as we go on to your gamma rays, so the wavelength is getting shorter. So please remember that as the wavelength gets smaller, so its energy is also increasing, and vice versa. So as the wavelength is increasing, so the energy as well is also decreasing. Now let's talk about the different properties of your EM waves. So basically, so they can travel in a vacuum. So a vacuum is like no air, no solid, no liquid. So basically, just imagine your outer space. So they do not require a medium in order to move around or to carry them. Next, EM waves, so they travel at a speed of 3 times 10 to the power of 8 meters per second in a vacuum. So that is your speed of light. And also, there's a relationship of your frequency and your wavelength, which will determine your speed. So that means if the wavelength is longer, then that means the frequency is also lower. And if the wavelength is shorter, then the frequencies are higher. Okay? So therefore, so like for example, so your radio wave, so it has your longer wavelength, so that means it has a lower frequency. While your X-ray, which has a very shorter wavelength, so that means it has a higher frequency. Now let's go to your first EM wave, which is your radio wave. So your radio wave has the longest wavelength and the lowest frequency. So also your radio wave is commonly used to transmit information from an antenna of a broadcasting station to the antenna of your radio. So not only that, So your radio wave is also used to gather information of your distant stars or of your distant planets using our radio telescopes here. Also, the good thing about radio wave is that it is not blocked by conditions of the Earth's atmosphere. The next type of wave is we have your infrared. So your infrared is given off by every object. So actually the amount of energy that is released by your infrared depends on the color and temperature. So you can just look at here the scale and it will tell you the rough estimate of its energy level. So basically, so a warm, dark colored object emits or releases more infrared radiation than a cold, light colored object. So just like this picture. Also, in the dark, so human beings can see, not necessarily see, but can differentiate the difference from plants with the help of your infrared glasses or binoculars. So these infrared glasses are used by soldiers in hunting your bad guys or terrorists in the forest area. Also, your infrared rays are very useful to pilots, especially if they are traveling at night or in a foggy weather. Also with your infrared, so you are using it at home, so especially if you have your controlling electronic devices such as your TV sets or CD players or even slide projectors, so they contain a small infrared transmitter for changing programs and for making other adjustments. So the next one is your visible light. So your visible light is the only EM wave that can be seen by our eyes. So our eyes here is sensitive to this range of wavelength, wherein all the other wavelengths outside our range, so we are not able to see them, so therefore they are invisible. So the visible light, so this is like your white light. So your white light has consists of at least 7 colors here: red, orange, yellow, green, blue, indigo, and violet. So as you can see here, so your red color here has a longer wavelength. So the frequency is only less. So look at the wavelength distance, right? So the frequency is only 1, 2, 3, and 4. However, with your violet, so it has a shorter distance of your wavelength. So see, however, the frequency is increased. So the frequency for violet is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So please remember, so as we move from red going to violet, so the energy level is increasing. However, if we move from violet to red, so the energy level is also decreasing. Next is we have your ultraviolet radiation. So its wavelength is shorter than the visible light, but is longer than the X-rays. So basically in your ultraviolet radiation, so this wave is invisible. However, some animals can see them, so just like your insects, like your butterflies, so they can see this ultraviolet radiation. Also, so your ultraviolet radiation, so coming from the sun, so when you go to the beach and you're not using your lotion or UV lotion, so it can cause skin sunburns. Okay? So also your ultraviolet radiation helps to produce vitamin D of our body in your skin. Next is we have your X-rays. So I think you've heard this one somewhere in the hospital, right? So your X-ray has a smaller wavelength than your UV rays. So therefore it has higher energy. So therefore X-ray is more powerful than your UV rays. Also, so it is most commonly used in medicine. So that's because your X-rays cannot pass through your bones. However, it can easily pass through your flesh or your muscles. So also with your X-ray, so they can easily penetrate solid materials. And if, like for example, in this case, so taking an X-ray of your lungs, so this black here is your photographic film. So your X-rays can be seen in your photographic film in the same way as light. However, so the good thing of your X-ray is that you can be used to diagnose you or to help you in knowing your disease or problem. So Prolonged exposure, or shall we say longer exposure to X-rays, is dangerous as it can cause severe damage to your body tissues. Remember that your X-ray has a higher energy. So the higher the energy the EM wave has, so the more dangerous as our body is exposed to it. Okay, and finally is we have your gamma rays. So your gamma rays is the smallest or has the smallest wavelength in all EM waves. So that means it is the most powerful of all EM waves. That's because it has a smaller wavelength, so therefore it has a more frequencies. Also, so these waves are produced by your radioactive atoms such as your cobalt-60. So, and also in nuclear explosion, just like your nuclear bombs. So, gamma rays are very helpful in the field of medicine. So, if you have like tumor or a person has tumor or cancer, so your gamma rays are used to destroy that tumor, just like this picture. So this is the summary of your useful applications of your EM wave. So you can use this one to answer your science book. So we have here the collection of your EM waves. You have here your radio waves, which are commonly used in TV and radio broadcasting, infrared for navigation at night or in foggy weather, or in remote control keypads. Also visible light, which allows us to see. UV rays for production of vitamin D or even checking signatures. X-ray for photographs, X-ray photographs. And finally, we have your gamma ray, which is used for radiation therapy or for killing cancer cells. So fortunately, there is no computation for this topic. So I will be giving you your science book as your homework. So please answer pages 83 and 84. So this is the end of the lesson for this video, M3. So once you're finished, so please upload it in your Google Classroom. And that's all. So if you have any questions, you can just message me on the line group. So once again, thank you for listening and have a nice day.